Assalamu alaikum. My name is Hassaan Ahmad and I am your course instructor for the course of data structures and algorithm. Today we will discuss the quicksort sorting algorithm, which is a part of a sorting algorithm category in data structures and algorithm course. How quicksort is different from the previous discussed sorting algorithm, how this algorithm approach and what the methodology of this algorithm, and lastly we will dry run this algorithm by using a sample example code and a sample array of random values. As clear from the name, the quicksort sorting algorithm is the most commonly used sorting algorithm because it is the fastest non-generic sorting algorithm in practice. As compared with the previous discussed sorting algorithms like bubble sort and insertion sort, quicksort is fastest known algorithm because of its approach and technique it adopts. Now let's discuss the previously discussed sorting algorithm. Starting from the beginning, first sorting algorithm that we discussed was the bubble sort, which was the initial entry point of sorting algorithm. Bubble sort basically sort the algorithm on the basis of the property of bubbling the largest element to the end of the array. After each bubble cycle, the largest element in the pool, the largest element in the array is bubbled up or moved towards the last element of the array. In this way, the bubble sort the unsorted sequence of array into a sorted sequence of array. Bubble sorting algorithm uses the approach of comparisons, individual comparisons, pairwise comparison. It compares two individual values and then on the basis of comparison it tests the values whether the value is greater or smaller, and in this way it bubble ups the largest value to the end of the array after a complete cycle, and repeat this process with size s-1 or n-1 again. Second previously discussed sorting algorithm was insertion sort. Insertion sort sorting algorithm uses the approach of insertion. It divides the unsorted array into two sections, a sorted sequence and an unsorted sequence. The sorted sequence is the one which starts from the single element. Initially, a single element is a sorted element, while the remaining section is unsorted. It grows this unsorted sequence, it grows the sorted sequence, and eventually the unsorted sequence shrinks. Thus, insertion sorting algorithm use the approach of insertion. The methodology it adopts is insertion sort. Now moving towards the last previously discussed sorting algorithm, which is merge sort. Merge sort sorting algorithm lies in the category of divide and conquer. It uses the approach of divide and conquer. In divide and conquer, the recursive algorithm for the merge sort that we discussed in the previous class uses the approach of divide and conquer, in which it finds the mid value and divide the array into two sections, and then apply the recursive algorithm to further divide the array till it achieves the base case, which is the individual block or individual element in that array, and then it starts merging up those values and combining the unsorted array while applying the sorted formula. Now let's compare these previously discussed sorting algorithm with the quicksort algorithm. Quicksort algorithm has following characteristics. It uses the approach of divide and conquer. It is also a class of comparison sort, and lastly, which is the most distinguished character of quicksort, which discriminate the quicksort from the merge sort algorithm, is the pivot based sort. The quicksort algorithm is a pivot based sort, which means it selects a pivot element, and on the basis of pivot element it applies the sorting algorithm. Quicksort algorithm is different from previously discussed sorting algorithm in the sense that it uses a pivot. It is a pivot based sort. It selects a pivot element from the existing values, and on the basis of that pivot it applies the sorting algorithm. The property which the quicksort algorithms adopt is that it selects a pivot, and on the basis of pivot it divides the array into two sections. The values in the array which are smaller than the pivot will move towards the left side, will be pushed towards the left side, while the values greater than the pivot pivot will move towards the right side. In this way, two sections are created, one on the left side while one on the right side. The values on the left side will be smaller than the pivot element, while the values on the right side will be greater than the pivot element. This is the basic property of the quick sort, which means the values on the left side are smaller than the pivot, while the values on the right side are greater than the pivot. Now moving towards the approach and methodology, how it works. This is the main core question of this session. How the quick sorting algorithm works. How it is different from the previously discussed sorting algorithm. So the main difference between the quick sort algorithm is that it selects a pivot. It is a pivot based sort. So basically how it works, it selects a pivot from the pool of element or from the unsorted array. It selects a random pivot value. This is a clear picture of how a quick sorting algorithm works. From the beginning, you have a pool of elements from where the quick sort will select a pivot element. And as you know, as you can see from the name, pivot is basically a point around which we can rotate an object. So basically we are using the same approach here. We will select an element as a pivot and we will rotate the elements on the basis of this pivot. For example, the value is 65. So if the value of pivot is 65, then the value smaller than the pivot will be on the left side, while the values greater than the pivot element 65 will be on the right side. For example, 75 will be on the right side, while the value 31 will be on the left side, as the value 31 is smaller than 65 and the value 75 is greater than the 65, which is our pivot element. While selecting the pivot, we have created two set of pools, one on the left side, one on the left side, while other on the right side. And after this, on the bottom you can see we have to repeat this recursive algorithm again on the other two sides, from left and right side. Now let's break down this complete picture into steps so we can understand how a quick sorting algorithm works. Step 1 is the basic step, which is selection of pivot. You have to select a pivot element from an unsorted array or from a pool of elements. For example, in this picture, you can select 65 as a pivot element. Step 2, move values around that pivot. Now you have selected the pivot in the step 1. Now the second task or the second step is to rotate the values or move the values around this pivot. For example, the values smaller than the pivot will be on the left side, while the values greater than the pivot will be on the right side. Now you have to apply the quick sort on the right and left part, which are created on the basis of pivot selection. After selection of pivot, you have divided the array or the set of values into two sections, left and right. Now you have to apply the quick sort algorithm on the remaining section, left side and right side. Now let's discuss the recursive definition of quick sort algorithm. First, you have to place the pivot. Place the pivot to its appropriate position such that the property holds. The property, which is simply that the values greater than the pivot will be on the right side, while the values smaller than the pivot will be on the left side. Next, quick sort the left part, and then finally quick sort the right part. Now let's discuss the pseudocode for the quick sorting algorithm. First, we have a function definition with three parameters. First one is the array, which is represented by A. Next is the first index of the array, which is represented by the first. Then the third and last parameter of this function is last, which represents the last index of the array. Then comes our base condition, which is if first is smaller than last, which means the last index must be greater than first. This is our base case. Next, we have method call, which is partition with the parameters A, first and last. This method will return the index of pivot element after placing the pivot on its exact position. The partition method will place the pivot on its exact position where it should be sorted, and then it will return the index of pivot -1. Next is the quick sort algorithm recursive call for the left side, and then there is a recursive call for the quick sort element for the right side, for the right part. Now you can see the quick sorting algorithm with comments. First one is the base case, which checks the base conditions, whether the base condition is true or false. We have to recursively call the quick sorting algorithm till it achieves the base case. Next is the partition call, as I discussed before. Then comes the recursive call for the smaller side, and then comes the recursive call for the larger side. Or in other words, first is the recursive call for the left side, then it is a recursive call for the right side. Now let's discuss the partition method. The partition method is the method which is doing the job of sorting in this scenario, while the quick sorting algorithm is doing the recursive calls to divide the unsorted sequence in such a way that the quick sorting algorithm property holds, which is the basic property is the pivot element is always small, the values on the left side of the pivot are always smaller, while the values on the right of the pivot are always greater. So let's see the partition method. The method has three parameters. First one is again the array, second one is the first, which represent the first index to be sorted, and last one is the last, which is the last index of element. Next, in the beginning of this pseudocode or in this method, we select last element of the array as a pivot. In this step, the first step, we are selecting the pivot so that we can apply quick sort algorithm on the basis of this element. Next, we have iterator I, which initialized with -1. The value of I is initially initialized with value -1. It will point towards the values which are smaller than the pivot, values smaller than the pivot. Next, there is a loop which will iterate from the index, starting index, from the first to last -1, or in other words, from 0 to size -1 of the array. In this case, the for loop has a condition, if condition, which is our test condition in this case, the condition in the for loop is a test condition. The test condition tests whether the pivot is greater or smaller than the value, or the value compared with the pivot is greater or smaller, so that we can adjust the value on the left or right side respectively. If the value is true, if the test condition is true, then we have to iterate the value of I and swap the value of array at index I and with the value of array at index j. And in case of if the test condition is false, then we have to do nothing, we take no action. And the lastly, when the for loop reaches its condition, its iteration condition, when it's terminate in case of size -1, lastly after completion of for loop, in last it swaps the last indexed value, which is our pivot element, with the I plus 1 indexed value, and lastly it returns the I index to the method. Now you can see the comments which elaborates the pseudocode line by line. For example, in first line we had selected the pivot, selecting last element as pivot. In next line, index of smaller element, I will point the index of smaller element. Then there is a for loop which will start from first to last -1. Then we have a test condition, and after the check of test condition whether it is true or false, it will take action according to its condition. And lastly, after the completion of for loop, it will place the pivot at its exact position. Alright, let's start the dry run for the quick sort algorithm. Now you can see I have created a random array containing the values 23, 21, 12, 11, 44 and 8. Now we have to select the last element as pivot element. So I will mark the last element to represent as pivot with red color. Now the last element is pivot element. We have two iterators we have seen in the pseudocode section. The I is initially pointing towards the -1 or initially holding the value -1, while the j starts from the 0 to size -1, or in other case the j starts from the first till last -1. Alright, we have a test condition which checks the pivot element with the array value. For example, the value is greater or smaller. It's the basic test condition which is a part of our pseudocode in the partition method. Next, after this check of condition, we have to take action. In case of true, we take action. In case of false, we do nothing. We take no action. In case of true, we have to iterate the value of I and swap the value of ith index with the value of jth index. Now let's start this dry run on this random array. Starting from the first, the value of j is 0, as I have discussed before, because it is a loop variable, loop incremental variable. It's a loop iterator. Now currently I is -1, which is outside the scope, outside the boundary of this array. I will be pointing at the values smaller than the pivot. So currently we have not found any value which is smaller than pivot. Now let's start. First, we have to check the test condition. The value at jth index, which is 0, is 23, which will be compared with the pivot element, which is currently 8. So the condition is false. 8 is not greater than or equal to 23. Currently, the jth index is pointing at 0. J value is pointing at 0th index, which is this one. So it is holding the value 23. That's why we had checked the test condition of 23 smaller or equal to 8, which is currently false. In case of false, we take no action. And since we are taking no action, the loop will iterate. Now the value of j will be incremented with 1. Now j will be incremented with 1. After increment, the value of j is now 1. J is now 1, which means now j is pointing at index 1, which holds the value 21. Again, now we'll check the test condition, whether the condition is true or false. Let's check the test condition. The value of jth index is 21, which will be compared with our pivot element, which is 8. Again, the condition is false. 21 is not smaller than the pivot element. So we will take no action. As we are not taking any action, the loop will again iterate with value 1. Now the jth index will point towards 1. Now the j index will point, the value of j will be 2 after increment. Now we have to check the condition. For example, currently the j is pointing at second index, which holds the value 12. Let me draw the value. Let me draw the arrow, which is this one. Now again we have to test the condition in our third iteration. Now the value is 12. 12 again compared with the value of pivot, which is not smaller than the pivot. Again the value is greater than the pivot. So we have to take no action in this case. After this, again the value of j will be incremented, and after increment the value of j is now 3. The value of j is 3, which means now the j is pointing at index 3, which holds the value 11. It's pointing at this one. Now again we have to check the test condition. Currently the value at jth index is 11. 11 will be compared with our pivot element, which is 8. And after comparison, again the condition is false. 11 is not smaller than our pivot element, which is 8. So in this case, again the value of j will be incremented by 1. And after increment, the value of j will be 4. Now the j is pointing at 4th index, which means j is pointing at the value at 4th index, which is currently 44. Let me draw this one. The arrow will represent the value j is currently pointing at. Next, the test condition again. In this case, the test condition is 44 smaller or equal to pivot element, which is 8. Again the condition is false. After we have checked this condition, we have to take action, and in case of false, we have to take no action. And in case of no action, we have to increment the j value. And as you can see from the pseudocode, the j will iterate from index 0 to size -1 or last -1. In this case, we have achieved this case. So j will not increment now. The j loop, the loop which is incrementing the value of j, is completed. And after completion of loop, there was a statement which swaps the value of last index with the value of I plus 1, because we have not found any value which was smaller than the pivot element. We have to place the pivot at its exact position, which will in this case will be the I plus 1. I is currently pointing at -1, and after increment I will point at 1, and after increment of I, the value will be 1. As you can see, the value of I will be 0. The value of I will be 0, and currently the first time the I is pointing at a value which is in the scope of this array. For example, this one. Now the value of pivot which is at last index will be swapped with the value at I plus 1, which means I plus 1 index is this one, which will be swapped with this one. So after swapping, the value will be, the value of 23 will be placed at the last index, while the value 8 will be placed at the first index, which is 0. Let me update this. Now the first index hold the value 8 and the last index hold the value 23. Now again, this was the first call of partition method. Now the call returns with that index I, which is currently 0. Alright. Now the remaining section on which the quick sorting algorithm will be applied will be I plus 1, which is this one. I am representing with a subsection. Alright. Now we have to apply again the recursive algorithm and repeat this process according to the algorithm. As we have seen the complete dry run of the quicksort algorithm, after one complete cycle, you guys have observed that the pivot element has been placed at its exact position, which was the first index of the array in the current scenario. And we will see how the selection of pivot is an important factor in the performance of the quicksort algorithm in the future sessions. In the future sessions, we will discuss the selection of pivot, how it can affect the performance, and how it changes the approach of quicksort sorting algorithm. Inshallah, next time we will discuss the sorting algorithm. Inshallah, next time we will discuss the selection of pivot in detail. Allah Hafiz.